Hey guys, Aaron here. Welcome back to our Django Python tutorial where we're teaching you how to build a website. And in the last episode, if you don't remember, we added these few models and created some migration scripts to add those tables to the database. And in this episode, we're going to connect to Postgres and add all of our models to the Postgres database. And we're also going to stand up some Docker instances for both Postgres and the website so that it's easy for us to deploy the app once we're finished with it. So let's get started. All right, the first thing we're going to do is create a Docker image. If you're not familiar with Docker, it's basically a way to kind of package your app into something called an image, which can be run on pretty much any hardware. So it's really good for deploying your app because when you deploy up to the cloud, the architecture could be different and you just want to make sure that your app works in all of those different environments. You want to make sure that you have Docker downloaded for this episode. So if you just search on Google for download Docker, should be like the first link here. So the first thing we need to do to create a Docker image is create a Docker file. And the Docker file will basically tell Docker how to create an image for your app. So I'm going to close all these folders, and in the root directory, I'll create a new file. And let's call this Docker file. So by default, when you build the image, it will look for a file called Docker file, but you can also specify a different file name if you want when you run the build image command, but we'll just leave it as Docker file for now. And then the next thing that I want to do is specify a base image that we want to create this app image off of. So there are a bunch of different base images that you can use, but if you go to Docker Hub, you can look at all of those, and you can even create an app image and then make that a base image and build another app on top of that if you want, which we'll actually do later. But just know that you can use any base image that you want. So what we're going to use is the Python image, and specifically the slim version of the Python image, just to make sure that our image size isn't too large. So here are all the different versions of the image. You can use Python 3.9 if you want, 3.7, pretty much every version's here. And specifically the one that we're going to use is one of the Python 3.7 images, this one specifically right here, 3.7 slim. So to do that, I'm going to write a command in our Docker file and say from Python 3.7 slim. So this is just saying, use this as our base image. I'm going to set an environment variable for Python. You usually want to set this Python unbuffered environment variable. I'm going to say our working directory is /app. Basically just says that whenever we reference a file later on, it's going to use this app as the directory that we reference it from. So we'll keep all of our files in one directory so we don't have to worry about that. After I do this, I have this image, but it doesn't have any of the files that are on our local machine. So you can use a command to copy images from your local file system into the Docker image. That command is called copy. And I'm just going to copy in my requirements, the prod requirements, actually. And I'll copy that into our working directory, which is app. So I can do dot to reference that working directory. And then requirements /prod.txt. So again, I'm copying the file from my local file system into requirements prod.txt. Then what I'll want to do is actually install those dependencies in the Docker image, so that when we run our app, all the dependencies will be there. So I'm going to run pip install -r requirements prod.txt. So I should mention, when you're creating one of these Docker files, in addition to copying in all those files, you're getting your environment within this image set up so that it can run the app. So if you do any other steps to set up your app before you run it, you could do them in your Docker file. Doesn't mean that you want to do all of those steps. Like later on, I'll show you that you'll probably want to run your migrations in a different way, but just know that, this is what it's doing. We're setting up this image as like an environment that we can use to run our app later on. Next thing I'm going to do is copy a few more files. So I'll copy the manage.py file. I'm going to copy in the setup.cfg file that I created last episode. And then I'm going to copy the main app directory. I should mention that you could do something like this where you just copy everything that's in the local directory into your image, but we don't want to do that because we don't want to bloat our production image with something that might not be needed for it. Because, you know, the smaller the image, the better, the faster it is to deploy. I wouldn't recommend that for this step, but we'll actually do that later when we build a different version of the image. So the last thing I want to do is expose the port that this service is running on. And you'll need to do that for any Docker image that runs on a port. So I'm going to expose 8000 because that's what our service runs on. Now, one more step that I'm going to do is tag this version of the image. So basically you can create one Docker file and tag multiple different versions based on the steps. The steps will run sequentially, so it'll start at the top and go all the way down. After a certain point, you can make a new tag to signify that the next section of steps is to build a different version of the image. So this will be our production image. Therefore, I'm going to tag this as production. The other thing I should mention about Docker images is that each one of these steps is cached so that when you build the Docker image, if nothing changed, it will be really fast because it'll just use the results in the cache. So you generally want to write the steps out in a way where the things that are at the top are the things that don't change very often, like this environment variable in the working directory, and then the things later on, like the file directory and maybe the requirements, would maybe be at a later step because those things will change much more frequently than these things will. All right, so now we have our Docker file. We need to make our Docker image. To do that, I'm going to run a command, but I don't want to have to type this command out every time. So I'm going to create something called a makefile, which will create aliases for our different commands. So I'm going to create a new file in the root directory and call it makefile. Then within our makefile, we can specify a alias. Let's call it build. So this will build our Docker image. And then inside of this alias, we're going to type a command called docker build. We're going to specify a flag called force remove. We'll add a variable for any extra options that we might add when we run this command from our terminal. And then we're going to specify the name of the image tag, which will be saved inside of our local Docker repository. So I'm going to call this one Hacker Shack Website Tutorial. Every time we build it, we'll create a new latest image. So I'm going to say this is the latest. And then you'll have to specify a path to the directory where the Docker file is located. So since it's in the same directory as the makefile, I'll just put a period here. So I'll save that, and then I can go into our terminal. Now we can run the command make build, and it should run that alias that we ran earlier. And there we go. We have everything installed. So since we don't really have any dependencies and the code base is pretty small, it was really quick. And now I can look at that image if I type the command docker image. And so I created one earlier when I was testing this, but you can see that this is our latest image for the Hacker Shack website tutorial image, and that was just created. So I mentioned earlier that you can have different versions of your Docker image. Now we've already created one version here, but let's go down and create another version for development, because we're also going to use this Docker image for development because it will be much easier to get it running on a local development machine if we just start straight from the Docker image. So to do that, I'm going to specify my base image, and we'll say that the base image is the target that I created earlier. So from production, and we'll specify a new target. Let's call this development. And now we'll add some extra steps to add in the files that we'll use for local development. So the first thing, obviously, that we'll want to add is the dev requirements. I can say requirements / dev.txt, and we'll put that in the same directory as the production requirements. Now let's just run pip install to make sure all those are installed. And then maybe the last thing we'll want to do is copy everything that's in the local directory into our Docker image, just because it'll be much easier to test when we have all the files automatically being copied over. So I'm going to save that. And now maybe we can add another makefile command for building the dev image. So this command was building the production image because we didn't specify a target, but now it's going to actually build the dev image because it will just by default run everything in the Docker file. But you can specify a target if you want to only build the production image. So I'm going to call this command build prod, and then inside of here, I'll reference that make alias that I did earlier. To do that, I can use this syntax with the parentheses and the $ make, and then I'll run build and use that options variable that I specified earlier to say my target is equal to production. So I can save that, and if I go back to my terminal, I can run that make command, and it should build production target image. So there we go, and you can see that it didn't do those last two steps, but if I were to do the make build command again, you can see all of the dev stuff being built now. And since we're using the same image tag for this, it will just override that latest image that I showed you earlier using the Docker command. All right, great. So we have our Docker image for our application. So we could run some command to run a script within this Docker image to start up our server. But I had mentioned earlier that you might also want to run migrations for your database or even spin up another image for your database. And we don't want to have to open up several tabs in our terminal every time we want to run all those things. So luckily, there's an easy way to do that with something called Docker Compose. You can create a Docker Compose by making a file called docker-compose.yml for YAML. First thing I'm going to do is just create a service running our Python server. At the top here, I'm going to create a version. I'm going to specify a version of Docker Compose that we want to use. Let's use 3.7. And then I'm going to specify some aliases here for a couple different things. So this Docker image is going to be running inside of a container, which is basically like it's not quite the same thing as a virtual machine, but it's like a virtual machine. It's like another environment that's running inside of your computer. But you don't want to have to restart that every time that some files change on your local machine. So, if I were to go into one of these files and then modify something, I don't want to have to rebuild everything when I do that. So there's an easy way to say, okay, for this container, I want to use all the files in the host that's running that container. So that's by creating a volume. I'm just going to make an alias for this because it will be used by multiple services in our Docker Compose. And this, I'm just saying the local directory is going to map to our working directory in our Docker image, and we can cache some of that stuff if we. And now I'm going to create another section called services. So it expects a services block here if you want to run services. And then I'm going to create a service called website. So this will be the main container running the website. Inside of here, I'll specify an image, and this name of the image is Hacker Shack Website, which is the same name that we specified when we were building the image. And the tag, it was latest. So I'll set that here. And then we need to specify a command for our service to run. So it will take this command and run it inside of that image that we just created. And this will be the same command that we always use to start up our server, python manage.py, run server. And then one special thing that we need to do for this is actually say that our server is running on the port 0008000. And this is just some kind of like an issue with Docker Compose where you need to explicitly specify that or else it won't expose the service properly. So I'll just add that here and map that to port 8000. And then I'll have a couple more commands. One's to connect that volume that we made an alias for earlier. And I can reference that by using star and then the alias name that I defined up here. So I can copy this and then put this after the asterisk. And then I'm also going to need to map the port in the container to the port that I want it to run on my local machine. So we can just use the same port here. So I'll say 8000 maps to 8000. Save that, and then I'm going to add another makefile command to start our service up using Docker Compose. So let's go back here and create a command called compose start. Now there's a CLI tool that you can use to run Docker Compose, and that is docker-compose. There's a tool within that CLI called up, which will start up our services. Then we'll add a flag called remove orphans. And this is just going to remove any dangling containers that might have been in the last version of the Docker Compose, but not the most current one. And then we can use a variable here again for any options that we might want to run with the Docker Compose command when we run it from the terminal. So let's save that and then go back to the terminal and run that command. So now our service is running. We can go to our browser and refresh, and you can see that it's working. So if I navigate around the page here and go back to my terminal, you should be able to see some traffic. So that's great. One thing I also want to mention is if I go to a new tab and type docker container ls, I should be able to see that my container is running. The other thing I want to note is if I were to go back to my code and maybe make some changes in here and add a couple spaces, I can look at my app and it will automatically hot reload for me as well. So I can make changes locally and I won't have to build my image. The only time you'll need to rebuild your image is if you add some new dependencies in your requirements. All right, so maybe the next thing we want to do is add another service that will run our migrations for us before the website starts. So let's go back to our Docker Compose and create another service. This one will be called db_migrate. The name here is arbitrary. It could be any name that you want, but I'm just going to call it dmigrate because it's easy for me to know what it's doing. This is going to use the same image as the website because we will need to run some migrations that are part of the website code. And then let's create a command here that will run the migrations. So if you remember from last time, you can run Python manage.py migrate to run the migrations. And for now, this is just using a database that's being created within this Docker image, but eventually we'll run this on the Postgres database. For now, we'll just keep it as is because we haven't created that Postgres database yet. We'll have to add another section to the website service to say that we should start this service after the migrations have run. So that is called depends on, and we'll specify the name of the service here, which was db_migrate. Oh, and the other thing that I forgot to mention is that you'll have to use the same volume as the website. So let's copy over the volume and then restart here. And now you can see all of our migrations run. The other thing that I might want to do is add a command to stop Docker Compose services for running. So that one is just Docker Compose down, and I can specify the same arguments here as I did for our Docker Compose up. If you just Control-C to exit this process, it will keep the containers running in the background, but you can actually shut all of that down if you run make compose stop. So it will remove any networks and any containers that were running for your particular. You can go to our make file and type another command alias here. Let's call this compose manage -py. There's another tool as part of the CLI called run, which allows you to run any arbitrary command in one of the services that are running in your compose file, and it will start up any parent services that service is dependent on. So I can type the remove flag, which will remove anything that was created after running this command. Specify options again here as a variable, so we can pass in any options that we want in addition to what we've specified in here. I'm going to specify the service name, which is website, and then the command Python manage.py. And since we want to make this reusable, we'll just create a variable for the command that we want to run. So I can use this command to say make migrations for our application. So if I just take this command and run it in our terminal, I can say my manage.py command that I want to run is make migrations, and then it will automatically spin up the services and then create the migrations for us if we had things that we needed to migrate. But since we don't have anything, it should be fine. All right, until now we've been using this Sqlite database to store all of our data. Now, this isn't really something that you want to do when you're running your website in production, because especially if you're using Kubernetes, there's no guarantee that this file will be present on the machine. It might schedule new machines, and those new machines might not persist the data unless they're using like a volume or something. But generally, like, you don't want to do this, and especially if you're having multiple connections to this database, like, you don't really want to use a file. You want to use a database to store your data. So for our database, we're going to be using Postgres, which is a pretty common choice when you're using Django. Django is nice because it can connect to a bunch of different databases, but you can still use the same model code to interface with the data. So although we've created a bunch of models already for our apps, and we're using SQLite, switching over to Postgres for us should be really easy because we just need to change a few settings. Now, before we actually change Django, we're going to have to spin up an instance of Postgres in a Docker container from our Docker Compose file. So I'm going to go back to our Docker Compose file, and I will add another service called Postgres. Now, just like our image that we're using for the website, you can use an image to start a Postgres instance. There are a bunch of publicly available images online that you can use to do this kind of stuff. If you want to spin up Redis or Postgres or anything like that, you can usually find an image to do it. So I'm just going to say the image for this is Postgres. You notice that it has the same syntax as this. You can actually specify a path before your image, which points to a Docker Hub repo, but if you don't specify a path and the image doesn't exist locally, it will look up at the public Docker Hub repo for that. So we'll just say that we're using image Postgres, and this will just automatically pick up the latest version. Postgres runs on a port, so I'm going to say port and expose the port that Postgres runs on, which is 5432. This will allow us to look at the database from our local data viewer that I will show you in a second. Then we're going to need to specify a few environment variables. Now, these environment variables are required by this Postgres image in order to start running. One variable that's needed is the name of the database that should be created on first load. The second one would be a username and then a password that should be used for the database. So for us, because this is just a development database, we're going to specify this stuff inside of the file. And we'll do a different method for this when we actually deploy it to production. But for now, file is just fine. So I'm going to create another alias here called database variables. One will be called PostgresDB, and we'll just name this Postgres. This is a Postgres user, which we'll also just name Postgres for now. And then a Postgres password. Now, if you don't specify these, there are some default values that it will use, but we just want to make sure that we define these so that it's predictable. And we're also going to use these to connect from our service as well. So I'm just going to add another entry to this object. We'll reference the database variables. All right, now I can save that. Then we have to go into our settings for our Django app and modify our database. So I've already done this. I'm just going to copy and paste it in and then describe what I've done. So I'm replacing the default database with a Postgres database. And this is using a Postgres engine to interface between the models and the database. And then these three values are those environment variables that we set up, and a Postgres host. Now, I need to create all these environment variables in our Docker Compose file, but I can reference them by creating variables in the settings file. So I'm just going to copy paste this in as well. You can use the os.environ to get an environment variable. And so I've just specified the default as an empty string, and then it will try to get the value of the environment variable first before defaulting on that empty string. So I need to go back into my Docker Compose file and then modify this slightly so that we're also using the database variables in our service as well. We're going to have to use all of these variables, and I could just copy this environment key and put it in the website as well, but there's also another environment variable that we need to have for the Postgres host, and we'll probably have other environment variables in the future that are used by the website but not Postgres. So I'm just going to create another alias for app environment variables that will also reference the database environment variables as well. So it will take a combination of both a new set of variables plus this database variables. So I'll call this x app variables, and the alias will be app variables. So I need to expand the values that are in the database variables. To do that, I can use this double less than sign and then another asterisk database variables, and then the values of the variables that I want to add. So one of the variables that I added in the settings file was the Postgres host. So I can add that. Now the host is just going to be the name of the service, because Docker Compose automatically creates some network configs which map this name to a container that's running as part of this Docker Compose context. So I can just use Postgres as the name of the host, and it should be able to connect. So now we have these variables. I can reference these in my website service, and I'll probably also reference them from my DB migrate service because it uses the same image. So I've already done this, and I'll just copy and paste it in. And now I need to make sure that I have Postgres installed on my Docker image in order for it to be able to connect to Postgres. So let's go into our requirements file and add a new requirement for Postgres. So I've already done this in another tab, so I'll just copy and paste this. So the other thing that we have to do before we connect to Postgres is make sure that our Docker image has all the necessary dependencies in order to do that as well. So we have this Python dependency that helps us connect through Python code, but there's also some system dependencies that we need to connect to Postgres. So I've also done this in another tab here, so let me copy it in. And you can just copy these over. These probably won't change very often, so I'll just put it, maybe I'll put it after the Python unbuffered variable and the working directory, but before the requirements for the app. So let's save that. And now I'm going to go back to my terminal and run another make build, which will build the dev image for us. So now I can run make compose start, and our Postgres database should start. And you might actually get a couple errors on the first time. Sometimes the database starts after the migrate command runs. And you can, if you go into your Docker Compose, you can say that the migrate depends on Postgres. But there will still occasionally be a race condition where Postgres starts after DB migrate. So you might just have to run it 2 times on the first time that you start up the Docker Compose command. So as you can see, all of our migrations ran, and now we're connected to the database. So if I refresh this, you can see that the website's working. And since it's a new database, we won't have any of those super users. So I can't log in with my user from last time, but we will create one of those in a second. There is one gotcha though with what we've done so far. As you can see, these migrations have run, but if I were to stop and restart the Docker Compose, the database will be wiped, and then it will rerun the migrations on a clean database. The reason why that happens, and there's actually that error that I was talking about earlier again, but the reason why that this happens is because every time it starts up a database, Docker creates something called a volume, which will store the data for your database. And now the volume is something that is persistent across Docker Compose sessions, but if you don't specify a name of that volume, it will just generate a volume with a random ID. And it does that each time it starts up. So we're effectively creating a new volume every time, which means that there will be no data for the database each time we start it up. To get around this issue, we can just name the volume of the Postgres database. So I'm going to go back to my Docker Compose file and do that. So like the website, we can create a volume key on our Postgres service. And I'm going to name this one db-data. And db data is going to map to a directory inside of the Postgres image. So if you go read the Postgres documentation, it mentions that all of the data for the Postgres image is stored in this directory. So we're saying that we want to create a volume called dbData for this directory in the image. And any data that's stored in this directory in that image will actually get stored in the volume called dbData for this Docker Compose file. And then the last thing I need to do for that is just create another top level key called volumes with an empty key for the name of the volume, which in this case is dbData. So I'm going to save this and then just stop my Docker Compose, restart it again. We'll just do that twice to make sure that the migrations actually ran. And now if I stop this and then start it one more time, you'll see that it doesn't run the migrations because it's just reusing the volume that we've defined before. And I can actually look at this if I do docker volume ls. So you can see that there's a website tutorial dbData down here. Now these other few up here are just those volumes with the random IDs that I was talking about earlier. And you could remove these if you want, but we'll just leave them as is for now. So maybe the last thing we can do before we end this video is just create one more admin user using the Postgres database. So let me go and run my make compose manage.py command, and then we'll use the create super user tool that we used last time. So again, we'll call this admin. Okay, and now if I rerun the Docker Compose and then refresh my login page and use those credentials to sign in, you can see that we now have a user in our database, and we can still go to the admin page and add more user interests and other data if we want to add data that way. If you want to actually view some of the data in the database, you can use this fancy tool that I like to use called POSTGRES. When you open it up, it has this little tab right here which you can add a connection to a database. So in mine, I just used my host as localhost and the port as the port that I exposed through the Docker Compose. Then my user is Postgres, my password is also Postgres, and the database name is Postgres because we've defined those in the Docker Compose. I can connect to the database and then see all of the tables in the database over here. So if I click on my auth user, you'll see that user that I just created through the compose manage.py command. All right, that's it for this video. I hope you guys enjoyed. In the next video, we're going to work on styling our website and building our front-end assets. If you missed one of the steps in the video, we do have all of our code uploaded to Patreon. So it's $5 a month and you get access to all the codes from every one of these tutorial videos. This does help us create more videos in the future, and it's super helpful if you guys support us on Patreon. But anyways, thanks for watching, and I'll see you guys next time.